I'm Brian Bonnell. I'm an applications engineer with Digitized Designs. Today I'm going to be showing you the Simscan, which is one of the smallest handheld metrology grade scanners in the world. This thing has a accuracy of around 20 microns, scans about 2.8 million points per second. As you can see see in my hand here, it's actually very small. It's very easy to hold. You've got laser emitters here and two cameras right here. Then you've got a series of just 4 buttons on the back side here that you have your play, pause, menu button, and a plus minus. We'll talk about those in a little bit. The case is here. The case is very small. Makes it very easy to transport, to take on an airplane, for instance. All right, so this works with crossing blue lasers. So blue light lasers are basically the state of the art of this technology. Traditionally, they were red lasers, but red lasers are much more sensitive to shiny surfaces, especially dark black surfaces, black shiny surfaces, chrome, and so forth. Blue light lasers, like this one, are actually much more adaptable as far as the surface conditions go. All right. So we're going to jump into scanning in just a second. A little background. This is actually a small 50 caliber cannon that my father and I made. And yeah, I'm going to scan this for you. The scanner uses targets. You must see 4 targets at all times. So what we're going to do first is do a marker point scan. This is not entirely necessary. You can actually jump right in and scan with it, but there's some advantages that I'll show you in a minute for doing a marker point scan. So we have, in this case, I have a couple different markers. So I selected the 3mm plus the 6mm. So you can use them simultaneously. It automatically will have the 3mm selected, and you have to select that one, the 6mm selected, but you have to select the 3mm separately. But it could use them in tandem with each other. All right. So like I said, we're going to start with a marker point scan, which is basically infrared. And you can go very quickly with this. All right. So you just want to hit it from a bunch of different angles. This is probably sufficient here. So I'm going to stop this. And it's running an optimization algorithm at this moment. So there it is, it's finished. So you kind of see you see the barrel here and so forth where those markers are. It's kind of fulfilling to see that. Okay, so earlier I talked about the advantage of going ahead and doing the marker point scan ahead of time. One is you do increase your accuracy because it allows the program to run through that optimization routine you just saw. Secondly, it allows us to set up what's called a clipping plane. And a clipping plane is a plane at which I can basically select this table to be that clipping plane, and the table and below will be recorded. So we're going to do a background plane here, and I'll just select a few here and set that up. That's how easy it is. So now we are ready to jump in. So I've got my settings here. I'm going to go to laser patch mode. Laser patch is the where we'll be able to activate the actual lasers. So now we're at a point where we're going to do our marker point scan, which is scanning our targets. But there's targets on the object and on the turntable, which is not always necessary. You could actually scan with this without any markers or targets on the object itself if you have sufficient number around the turntable, which is cool. This just helps later on, and I'll show you why again. Later future processes can be helped by having at least a few targets on the object itself, especially if it's something that you're going to be flipping, like the case of this cannon here, to get the overall scan. Okay, so now we're going to, as earlier I alluded to the idea that the advantages of a marker point scan. There's 2 major advantages that I see they're very common. Is it'll run through a optimization algorithm, so it tends to make your data more accurate, but also it enables you to set up a background plane, which is also known as a clipping plane. So this enables it to not scan below the table or below, which is handy. All right, So now we're going to go into laser patch and start actually scanning. There you go. You see it coming in. And I can, at any time, I can actually zoom in or out with the buttons on here. So this is cool. See, I'm zooming in. There's different modes. So it defaults to the zoom mode. So there are occasions where you're going to want to zoom in. So as I mentioned earlier, this scanner can scan up to 2.8 million points per second. So you can move pretty quickly. I like to do it in one orientation, kind of like this, moving my hand a little bit, spinning it around. Then I'll bring it up, changing angles. You got to remember, this is all line of sight. So I've got to, if I want to see into a crevice or an area, I've got to have the cameras both have to see within that area, see the lasers and how they bounce and bend and deform off of that area. All right, so this is actually fairly well scanned right here already. All right. Now we're going to do this. It cleans it up a bit. So you see I've got some extra stuff around here, mostly my hand. It has this really cool function right here, disconnected objects. And that will allow me to select everything that's not part of the main overall scan body, in this case the Canon. So it selected my hand and different things around here. So you can click that and then we can just click delete. All right, so now I'm going to do another scan. This time, let's flip the Canon over. So I'm going to be very careful because this can rotate here. So I want to make sure that I don't change the geometry of what I'm working with. It's just a little scanning tip. Got it right there. All right, so we're in a new scan now. We want to make sure our point density is the same, and we're going to do another marker point. Let's do another marker point scan. Or heck, this time I'm going to just show you. I'm going to just jump right in. There we go. We just jump right into scanning like this. And you see it's acquiring the markers at the same time it's actually scanning. So if you're scanning for very high accuracy for metrology type applications, then it's probably best to scan the markers first. And also if you want to use a clipping plane, but you can jump right in. Like this, and just start scanning. And the cool thing, one big advantage of markers too, is that if you lose orientation, in other words, or if it can't see enough markers, it just simply stops scanning. See, I'm shooting myself here. I have no markers on myself. So I can spin this around like this, completely around. Now, as soon as it comes back, do you see it flip around? It knows exactly where it is in space. So I don't have to worry about trying to keep geometry and texture and make sure I'm overlapping and all that. Like other scanners, I can just continue scanning wherever I am. All right, so I've scanned the heck out of that. All right, let's stop this. Now, talking about the clipping plane again, there's several things I can do here to get rid of this table. I can go ahead and just delete it by lasso selecting it, or I can actually do another background plane, which I like this little trick. So a lot of ways to do this. This software is This software is very flexible. So I can go right here and just say delete below, click it, and it deletes that. And then disconnected components, select that and press delete on my keyboard. And there we go. So I've got the other half of the Canon. So now somehow we've got to get these two together into one Canon. So that with this, especially with targets, is very easy. It's actually easy without targets, but even easier with them. So we can go here. So we do this marker point splice here. We select one that we're going to keep stationary, the other that we're going to move. And all I have to do is simply select common targets, which since I deleted the background, those are all gone. So I can click this, and over here we can see that they join together like that. Click OK. Now it's one object. It's one complete Canon. Then the last step here, and most of the time, the last step for this software is to create an STL, which is a polygonal mesh. Right now we just have basically point cloud data that we've combined into one, but we need to make it into a polygonal mesh that you could save out as an STL, an OBJ, something that you could use in another program, such as a program like DesignX or a metrology program. So we can do that. We're going to wrap this. So there, this is our final polygonal mesh here. So again, like I said, you can save this out as an STL and then use it in other upstream programs.